Greetings and welcome back. Today we'll be looking at cycloalkane nomenclature. This should be a pretty short and simple voyage into nomenclature because the difference between cycloalkanes and alkanes is simply that these include cycles. So when you think about making a cycle out of carbons, the most common one we'll start with, which is 6 carbons in a cycle. And so they would have to basically come all the way around. It doesn't have an end, obviously, like a circle. And this would be 6 carbons in a cycle. Right, the way that we name these, again, we're going to go back to starting with the word alkane, is when you have these guys in a cycle, you simply add the prefix cyclo to the very beginning. So in this case, I have 6 carbons. A 6-carbon chain is a hexane. So therefore, a 6-carbon chain that is cyclized would be called cyclohexane. Likewise, a 3-carbon cycle would be called cyclopropane, etc., etc., etc. There is no such thing as cycloethane or cyclomethane because the smallest possible number of carbons that can make a cycle would be 3. So they don't get any smaller than that. The rules, the IUPAC rules for naming whole molecules is exactly the same as it was before. So let's draw out a molecule. We'll use this one right here. And so once again, we need to look at this guy, and the first rule is to find our main chain. But it's really important to note that when you have a cyclohexane, or a cyclopentane or a cyclopropane or anything like that, your main chain has to either be the cycle itself or the carbons in a straight chain. You can never go back and forth. We could never include all 8 of these carbons as our main chain. So our options are either we include these 3 carbons right here that are part of a 3-carbon straight chain, or the 5 carbons that are in the ring. As you can imagine, 5 carbons is more than 3, therefore this would be our main chain, and these 3 carbons would simply be a substituent. The next thing we would need to do is number, but when we're numbering a main chain that's a cyclo group, we don't have any ends anywhere. So theoretically, you can start wherever you want. We could number 1 at the top, 1 at the bottom left, etc., etc. But remember that we always want our numbers to be as low as possible. So therefore, you would start numbering at the carbon with a substituent, because you can. So this would be carbon number 1. And since we only have 1 substituent in this case, it wouldn't matter if we went clockwise or counterclockwise, but this is America, so I'm going to go clockwise. And we would just do 1, 2, 3, 4, 5 like that. So the name of this main chain is a cyclohexane, or excuse me, cyclopentane. And the name of this substituent right here would be a 1-propyl. All right, so we could correctly name this whole thing as 1-propyl cyclopentane. And that is just fine, but I will let you know that you don't need to include the 1 in this case, and you usually don't. If there is a propyl or any single functional group or substituent attached to a cyclo, it's very clear that it's just attached somewhere, and because of symmetry, it doesn't matter where it is. Therefore, if you only have 1 substituent on a ring, we don't need to say 1 because it's just coming off somewhere, and no matter how you draw it, it's always the same molecule. If you have multiple substituents, so for instance, let's do this guy. Our main chain once again is the cyclohexane, right? Just that big cyclic group. And then the reason again is because that's the biggest one. And then we would have 2 substituents. I've got an ethyl group there and a methyl group right here. Well, either way I do it, I'm either going to have 1, 2, 3, 4, or 1, 2, 3, 4. So I've got something at 1 and 4, or something at 1 and 4, but they would be different. So how do I break this tie? Well, you simply do it alphabetically. So because ethyl comes before methyl, we would put the ethyl at the 1, and then again I'll go clockwise. You would just go in whichever direction gets you to the substituent first, and that would give us what would be 1 ethyl, 4 methyl cyclohexane. All right, let's see how you can do, and then we'll move into one more thing that's slightly more complicated. All right, so thinking back to what a carbon really looks like when it has 4 single bonds, carbon with 4 single bonds is tetrahedral. Tetrahedral means that in 3-dimensional space, that carbon doesn't have bonds sticking out like this. It's not completely planar. That's how we do Fisher projections, but it's not realistically how these things look. Instead, when they spread out in 3-dimensional space, they end up looking like this. It is tetrahedral. Hopefully you remember that from general chemistry. I'll bring in some little models to show you in class. But what this means is when you have a ring, the substituents coming off of it are either going to actually be coming out or going back on each of those spots. If all of those places are just hydrogens, then it doesn't really matter and we don't worry about it. But knowing that every substituent on a cyclic chain is going to be either coming out at us or going away from us, it lets us be a little bit more clear as to what a molecule could look like. So if I have something like this, where I have 2 substituents and exactly 2 substituents that are coming out at us or going away, we would say that they're on the same face of the molecule, and we would designate that as cis or same, and we would put that at the very beginning of the name. So for instance, you can see that the main chain of this one I just drew is a cyclopentane, and I have 2 methyl groups coming off. I've got one at position 1 and one at position 2. So I could call this a 1,2 dimethyl cyclopentane. But to be more specific, I would say that this is a cis 1,2 dimethyl cyclopentane. If you have 2 substituents and exactly 2 substituents that are coming off of opposite faces, so for instance, if I have a CH3 coming out towards us and a tert-butyl group going away from us, we would say that these 2 things are trans to each other. Trans. And so the name of this molecule would be that the main chain is a cyclohexane, right? And I have a methyl group at the top, a tert-butyl at the bottom, and I would number it so that butyl comes first. Remember, tert doesn't count in alphabetization. Butyl comes before methyl, so this would be a trans 1 tert-butyl 4 methyl cyclohexane. All right, that is it. I'd like you to practice this, and please bring your questions to class. I will see you soon.